All right, here we have a very simple, two very simple fractions that we're adding together. We have 1/4, 1 out of 4 pieces, plus 2/4, 2 out of these 4 equally sized pieces. Well, it seems like when we add them together, we should simply get 3 out of the 4 pieces. 1, 2, 3 out of 4 pieces. And that is exactly right. That's exactly what we get. We get 3/4. That should make sense to you. And notice that when we added the fractions, what happened? Only the numerators added. We did 1 plus 2. And the reason is, just like we said, we're adding 1 out of 4 pieces plus 2 out of 4 pieces. Well, that should give us 3 out of the 4 pieces. Okay, let's just look at another quick example. So let's say we have here 5 out of 12 pieces. And we're adding 3 out of 12 pieces. Well, it seems like if we take 1, 2, 3, 4, 5 of the pieces plus 1, 2, 3, we should just end up with 8 out of the 12 pieces. We should end up with 8 of those 12 pieces. And indeed, that's exactly what happens. When we add them together, we just now have a total of 8 out of the 12 pieces. Now, the thing that's allowing us to add is the fact that we're talking about the same sized pieces. Notice that corresponds to the fact that the denominators are the same. So we had 12 pieces, 5 out of 12, and 3 out of 12. So in other words, we were cutting our whole into 12 pieces each time. So every piece is the same size, so we can add them up no problem. We have 5 out of the 12 plus 3 out of the 12, we get 8 out of the 12. Okay, simple enough. What happens though if we have something a little bit different? What happens if we try and add something like, sorry about that, 1/4 to 1/3? So I'll write that out. 1/4 plus 1/3. Well, visually, it's not too hard to imagine. Sorry again. It's just going to look something like this. That's the total amount we have. But what would that look like as a fraction? Well, it turns out we can't write this as a fraction the way that it is. And that's because these pieces are not the same size. We have 3 different sized pieces, and so this cannot be represented as a fraction. Remember, one of the things that we stressed is that a fraction represents equally sized pieces. So for instance, 4 equally sized pieces. Here we had 3 equally sized pieces. But in this last example, we don't have equally sized pieces, so we can't write it as a fraction. So what can we do? Well, maybe we can cut our pie into smaller pieces so that they're all the same size. And we can do that using multiplication. So I'm just going to do something. I know you'll probably have questions about it how did I know to do this, or what's the technique? We'll talk about that in the future, but just follow along for a minute. Let's say I multiply this by 3 over 3. And let me make some room for myself here. I'm just going to bring that up a little bit. Well, we know how to do that multiplication. It's just going to be 3 times 1 is 3, and 3 times 4 is 12. So this is, shoot, I really want this to be smaller so I have more room. I apologize. So we have 3 over 3 times 1 over 4. 3 times 1 is 3. 3 times 4 is 12. Now, we already talked about in a previous video, when we multiply by a number over itself, that's the same thing as multiplying by 1, so it doesn't change the fraction. And you can see that 3/12 is the same as 1/4. It's the exact same amount. Here we have 3 out of 12 pieces. Here we have 1 out of 4 pieces, but we're still talking about the same amount of pie, or the same amount of the whole. It's just there's smaller pieces and we have more of them. Okay, same thing for 1/3. I want to do something similar. What I want to do is I want to do 1/3 times by 4 over 4. And now we have 4 times 1, that's 4. And 3 times 4, that's 12. And you can see that 4/12 is the same as 1/3. Let me show you. Here now we have 4 of the 12 pieces, but that's the same amount as 1/3. They're smaller pieces, but we have more of them. Well, hey, look it, what happened now? Now we have 3 out of 12 equally sized pieces plus 4 out of 12 equally sized pieces. This should end up being 7 out of 12 equally sized pieces. And you can see that here. If you count these up, there's going to be 7 out of the 12 pieces. Now this is the idea behind finding a common denominator. So notice our denominator ended up being the same. A 12 and a 12. And we needed to do that in order to add. Before we did that, we had something like this. We had 1/4 plus 1/3. We couldn't add those. Then we found this common denominator. In other words, we split the pie into the same number of pieces, and then we could add them. Okay, so this is the concept behind finding a common denominator. We will talk about the techniques of finding a common denominator in the next few videos. See you then.